All right, ladies and gentlemen, welcome to another episode of Young Learning. Here we're going to talk about lesson 2. Lesson 2 is about writing equations to model relationships. So essentially what we're going to do is we are going to learn how to go from just solving for numbers, like if you have all the numbers, to going, well, what happens if we don't know the numbers? We have to add some letters to it. That's all we're essentially doing in this lesson. So let's go ahead and get started on our first practical thing, our nice little warm-up here. So our warm-up is going to dictate that what are these answers going to be? 25% of 200, which is basically the same thing as saying what is 25% times 200? Okay, so 0.25 times 200 here. So we have that equals, well, what is 25? Well, we all know 25 of 100 is 25. So then what's 25 of 200? When you double it, that gives us 50. Okay. 12% of 200. 12% is basically 0.12 times 200. Or we can change this to 12 over 100 times 200 over 1. We know these cancel out. I'm going to use blue to help me cancel. These cancel out. The zeros cancel out. So then as you can see, the zeros cancel out. What's 12 times 2? That gives me 24. Notice how easy it is when you do fractions. Fractions help. What is 8% of 200? Well, that's the same thing. So instead of 0.8, it's 0.08. Remember, you have to move the decimal twice times 200. So, or we can split that up to 8 over 100 times 200 over 1. Get my little blue pen here. We cross out the zeros. Once we cross out the zeros, we have 8 times 2, which is 16. Boom, bada bing, bada boom. Well, here, what's going to happen is we are going to use P now. So instead of the percentages, we don't know the percentages, so it's going to give us P. So in this case, it's going to be 0.0P, because whatever number it is, you've moved 2 decimal places times 200. Or what we can do is P over 100 times 200 over 1. We know our trusty little blue line, cross out the zeros because the zeros cancel out. That means this is 200 times P. Oh, sorry, not 200. Just kidding. It is 2 times P. And that's essentially what we're doing. Okay. All right. Pretty easy. So, platonic relationships. We're going to talk about platonic relationships now. So, how platonic relationships work is basically there's a pattern to all these shapes. Every shape you make has a specific pattern. So, we have a tetrahedron. A tetrahedron basically has 4 sides. 1, 2, 3, 4. There's one in the back and one in the bottom. So, there are 4 faces. Faces are basically what you see, what the shape of it is. Vertices. Let's write that down. Faces are the shapes that you see. Vertices are the knuckles or the corners or the joints, wherever they're joined together. So the joints. Okay. And edges are the lines that are connecting the shape. So all the lines that we see. Okay. So in this case, how many shapes do you see? You have 1, 2, 3, 4. You have 4 shapes. Vertices, how many joints or how many joints or knuckles is 1, 2, 3, 4. So there's 4. And then edges, how many lines do you see? 1, 2, 3, 4, 5, and 6. There we go. So now let's take a look at a cube. We have a cube. A cube dictates that we have faces. Faces are the squares. So 1, 2, 3, 4, 5, 6. So there are a total of 6 faces. How many vertices do you see? So vertices, you have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 vertices. And then the number of edges, this one we count. There's 4 up here, 4 sideways, and then 4 up and down. So that gives me a total of 12. So 4 times 3 is 12. If you want to count, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And then a dodecagon. Dodecagon is basically almost like a soccer ball, or for people who do D&D, this is a D20. So this is a D20. So there are 20 vertices, there are 12 faces, and then there are 30 edges. We're not going to count those because that's a lot to count. So we're just gonna trust that they got this right. Okay. So now, what are my two observations? Okay. Complete the missing values of the cube, then make at least two observations about the number faces and vertices. We can take a look at those things. What are my observations? We know that edges is the highest. So we know that the edges are the most. We know that the edges are greater than the face and vertices. What else do we know? We know that if you take a look, all the numbers are even. Okay, what else we got? What else can we see? What else can we see? We know that if we add these up, we get something. We know that faces and edges added up together is bigger than the edges, so we can write that down. Face plus edges. Face plus edges is greater than, oops, not face plus edges, face plus vertices. Vertices is greater than the number of edges. Okay, so let's take a look at the next one now. If there are some investigation relations between the number of faces, edges, and vertices in all Platonic solids, for example, the number of edges is always greater than the number of faces. Another example is the number of edges is always less than the sum of the number of faces. Add them together. But let's take a look. What can we do? It says find another relationship with an expression with an equation. We can express this with an equation. Can we find that out? Well, let's see. We did talk about this. Face plus vertices. Face plus vertices gives me what? Face plus vertices gives me 4 plus 4, which equals 8. Well, that is 2 less than 6. Okay. Let's take a look at the next one. 6 plus 8. So face plus vertices. 6 plus 8. That gives me 14. Oh, wait a moment. That's again 2 less than the edges. Well, let's test the third one. See, third time's a charm, right? Let's do 12 plus 20. Oh my gosh. That gives me 32, which is again 2 less than the vertices. So we can set this into an equation, can't we? Don't we just take faces plus vertices and we subtract by 2, and that gives us the number of edges? Well, there's our answer. So face, ooh, that's a terrible face, but let's try that again. Let's see if I can actually draw a nice little F. Face plus vertice minus 2 equals the number of edges. Easy peasy, breezy, beautiful cover girl. Look at that. Look at that. F plus V minus 2 equals edges, because every time we add these together, subtract by 2, that gives us the answer of edges. 4 plus 4 is 8, minus 2 is 6. 6 plus 8 is 14, minus 2 is 12. 12 plus 20 is 32. 32 minus 2 is 30. So there's our equation. So let's go ahead and take care of these now. So how many edges would each of these solids have? Keep in mind that each edge is used in 2 faces, so I'll help you out. These are kind of rough. These are a little rough. I'm not sure what they're trying to get at here, but other than that, let me help you out with this. An octahedral has 8 faces and a triangle, and I can't even pronounce it. Icosahedron is 20 faces, so we know. Octahedron has 8. Octahedron has 8 faces. And we're going to talk about the edges. In this case, we're going to have 12 edges. Okay. And then we have the isohedron. So those faces is going to be 20. Number of edges we're going to have, in this case, is going to be 30. Okay. Help you out with that. They're all triangles. These are all triangles. So if you have 8 faces, that means you have to have 12 edges because they all the triangles touch each other. Same thing with this one. If you have 20 faces, that means you should have 30 edges because all the triangles are touching each other. Okay. So use your discovery from the activity to determine how many vertices each have. Well, we have our formula. We just have to shift it so we can find V. So we do need to find V. Okay. So finding V is our main objective here. So how do we find V here? Well, we can take our formula and we can move things over because we have E and we have the 2 and we have the F. So let's move things over. We talked about this a long time ago. Okay. We talked about this a long time ago. If we have F plus V minus 2 is equal to E, we're going to move things over. Moving things over required us to do the opposite of it. So instead of subtracting 2, we're going to add 2 to both sides, right? So when we add 2 to both sides, we get F plus V is equal to E plus 2. And then we have to get V by itself. So in order to do that, we have to subtract F from both sides. So if we subtract F from both sides, we get V is equal to E plus 2 minus F. Okay. And that's how we're going to find V. So let's take a look at our 2. So our O, our octahedron, is going to be V is equal to number of edges is 12 plus 2 minus number of faces, which is 8. So that gives us an answer of, drum roll, 6 vertices. If we count this is going to be 14. 14 minus 8 is 6. Let's do our icosahedron. That's going to be, instead, we're going to have faces. We have edges, which is 30. Okay, oops. Don't forget our V. V is equal to 30 plus 2 minus the number of faces, which is 20 right here. And that gives us 32. 32 minus 20 is 12. There we go. Okay. So, now we have to look at all 5 plutonic shapes. So, all 5 of our plutonic shapes. The tetrahedron. We're going to talk about the tetrahedron, the cube, and what else? Tetrahedron and the dodecagon. Those, how many faces meet each other? Well, we can take a look. Tetrahedron, it looks like on the corner, we have how many faces meet at the vertex? So at the joint, how many faces? 1, 2, 3. So 3. Cube also at the joint, we have 3. And also at the tetrahedron at the corner, we have 1, 2, 3. So it looks like there are 3 faces touching each vertice. 3 faces. Okay. Now we gotta look at our other ones, which is the octahedron. In this case, it would be 4. And the last one is the isohedron, which is going to be 5 faces. All right. So again, it's just asking you to determine just kind of by deduction on this. This is all geometry. We should have done most of this in geometry. Tetrahedron, cube, and dodecahedron. Those are all. These 2 are a little more obscure, but this is how we find it. Now, let's get to the nitty-gritty here. The nitty-gritty is exactly what we're doing in problem 2.3. Problem 2.3 requires us to actually write a representation, an equation that actually gives us what we want. So we want an equation here. Oh my God, my pen doesn't like me. Okay. Yep. So an equation that does this. So let's take a look at the first equation. We have blueberries are $4.99 a pound. Diego buys B pounds of blueberries and pays $14.95. Well, this one's exactly like the pizza problem we did on the other day. So the pizza problem is basically how many pizzas you're going to order times what the price of it. Well, we have the pounds. We have how much it is per pound. And this is how much he spends. So all we're going to do is write an equation. So this is $4.99 times, not plus. This is going to be times B. And that should equal to $14.95. Okay? Fairly easy. There's our equation. Remember, an equation has to have an equal sign, so you have to make it equal to something. Well, let's take a look at the next one. The next one states that blueberries are $4.99 a pound. Jada buys P pounds of blueberries and pays C dollars. Well, they just changed $14.95 to C. So we're using the same equation. Nothing changes. It says pounds and pounds per dollar and how many pounds. So all they did was change $14.95 to C. So that means here what we're going to do is $4.99 times B, and that should equal C. Because easy peasy, this is basically the total. Let's see C. Blueberries are D dollars a pound. Lynn buys Q pounds of blueberries and pays T dollars. Well, they just changed everything. They just basically said no more $4.99 a pound. Everything's a letter, but we've done it twice, so third time's a charm. We can just replace the $4.99 with whatever letter they give us. They also changed the letter, so be careful. So first one is D, so we know it's going to be D times, in this case it's going to be Q now, and then that's equal to T dollars. Okay? That's basically it. We're just changing our equations so that way they work out properly. Okay? Oh, now let's take a look at this. These three look like they're different. So Noah earns N dollars over the summer. Mia earns $275, which is $45 more than Noah did. So we can kind of write an equation. We know that Mia earns $275, and we know that Noah is $45 less than that. Mia has $45 more than Noah. So our equation is going to state that we know for a fact that Noah plus $45 must equal what? Mia, $275. There is also another way to write this equation, or we could state that how? We can state that 275 minus 45, and that gives us the amount Noah has. So there are two ways to write this equation. You can either add 45 to Noah, which equals 275, or you can subtract Mia and Noah's together to get subtract Mia's by 45 to get Noah's amount of dollars. Okay, pretty easy. So now it's probably going to tell us to do the same thing. It's going to get rid of a number and replace it with the letter. So all we're going to do is try and figure out which one's going to replace. Noah earns V dollars over the summer. Mia earns M dollars, which is 45 more. So they took out two letters here. So if they're going to take out two letters, we know Noah was N, but now they changed it to V. So we know that N becomes a V. We know Mia was 275, which changes to M. And then 45 stays the same. So we know that this is going to be a V plus 45 is equal to M. So there we go. So we know V plus 45 is equal to M. Or, in that case, what do we want? M minus 45 is equal to V. So again, N and V are interchangeable. It just depends on what letter they're asking you to do. Last one, obviously they're going to get rid of the 45 on us. We've already established that. Noah earns W dollars, same thing. So instead of N and V, they change it to W. Mia earns X dollars. So instead of M, they changed it to X. And then which is Y dollars more than Noah. So we're changing the 45 to Y. So which means that we know Noah becomes W instead of V. Plus, and instead of 45, we go Y is equal to, and then Mia is X. So W plus Y is equal to X, or we know x minus y is equal to w. Easy. Easy peasy. Okay. So, how are the equations you wrote for the blueberries like the equations you wrote for me and the Noah's earnings? How are they different? So, we are going to do both. How are they the same and how are they different? Well, we know for a fact both of them use 3 values to calculate. Okay? Both of them use 3 values to calculate. Or this is the same. What else do? They are also quantities. They're all quantities. They all have a dollar amount and quantities. So I would say that it's about the same. They all use 3 values. How are they different? This is the same. How are they different though? Okay. Well, in the first case, the easiest one to think of is one is multiplication. One uses multiplication. And the other uses addition. Okay. One uses multiplication, 499 times b. The other one uses addition, b plus 45. Okay. What else is there? One uses pounds. The other one uses pounds. So weight. And the other is just all dollar amounts. Okay. That's basically what it is. Basically what we have. Those are my two similarities and differences. All right, moving on. We're almost done. Look at that. This is a very quick and painless chapter. This one right here. This one's going to talk to us about taxes. We talked about taxes. The taxes of a scale on the sale of a car in Michigan is 6%. Well, there are several ways to write 6%. How do we write 6%? Well, in one case, this is going to be 0.06, or we can write this as 6 divided by 100, correct? 2 ways to do that. We're going to know what that is after when we get there, okay? So, the dealership in Ann Arbor, a car purchases also involves a $120 miscellaneous charge. Wow, they are screwing us. Look at that. $120 miscellaneous charge? What are they miscellaneous charging me for? Huh? Not fair. Not fair at all. But anyways, let's take a look. There are several quantities in the situation. Original price, sales tax, miscellaneous charge, and then the total price. So write an equation to describe the relationship between all the quantities. This is exactly what we did in the pizza. Pizza, we had taxes, so we had to learn how to deal with taxes. Most of the time when we do taxes is always the amount plus the amount times the taxes, and we add them together. So in our first case, the original price is $9,500. So we know that $9,500 is going to be on here. $9,500. Well, we know total price. We have to talk about total price. So we have to write an equation. See, again, it says equation. So we know T is equal to 9,500 plus 9,500 times 0.06. And there's our total. Well, we're missing something. What are we missing? Our miscellaneous charge. So our miscellaneous charge says that this is $120. There's my equation. T is equal to 9,500 plus 9,500 times 0.06 plus 120. Easy. Let's try it again. Instead, my original price is going to be $14,699. So in this case, we know our total price is going to be $14,699 plus what? Again, $14,699 times 0.06, and then add that to 120. Okay? The next one. Total price is $22,488. Well, we are changing it, so we have to change our original price. So we need to know what the original price is. Well, if we don't know, we have to make up something. So in this case, our original price is going to be P. We're going to say original price is P. Okay? So then total price, we're going to use the same equation. So total price is 22480 is equal to, and then we don't know the total price, so that the total price changes. So we know this is going to be P plus P times 0.06 plus 120. And there you go. We just swapped them. Instead of having total price being a letter, we have original price being a letter. Well, last but not least, obviously, if I don't know anything, this is the last one. We don't know anything. We only have original price. We don't even know what total price is. So we have to go back to our total price, and we have to create a letter for total price. So in this case, it's going to be T. So we know it's going to be T is equal to P plus P times 0.06 plus 120. All right. And there you go. Easy peasy. Rocking it out. Well, so how would each equation you wrote change if the tax of the car rate becomes a letter, R%? So there are two ways to write this. You can either say this is either 0.0R, or what else can we write? We can also write this as R over 100. So let's rewrite the equation. I'm just going to take my first equation and then move it down and then replace it. So how do we do that last part? Okay, well, we're going to replace 0.06. Everything else stays the same. We know that T equals P plus P times, and then we know that this is going to change to R divided by 100 plus 120. And there you go. Let's write that 120 a little better. 0. Okay, and that's how we rewrite it. You can also change this to 0.0R, and you would have gotten the same answer. So what is this lesson telling us? The summary. The lesson is telling us that we can always go from prices or values that we know, values and prices that we know, and we can convert them into actual letters to something that we don't. Okay, in this case, we said that the cost is $7 per person for 108 days. You have 24 students and 3 teachers. Now, the biggest thing is we talked about this with the pizza party. Those two values, I'm going to circle them in red. These two values are subject to change. Why? Because people could be absent. Okay? Because people are absent, we don't know for sure if it's 24 and 3. And that's why when we simplify this, we have 24 plus 3. Instead of 24 plus 3, they just change it to S&T. And then from there, S&T, what happens if our bus charges change? If our bus charges change, then we're just going to change this to a different letter. So all in all, you guys should know how to progress in this situation based off of what you know. And this is what we're going to get into as we get into later into the units of how to create equations by critically thinking, oh, these are the things I have, and we're going to switch them out. All right. Well, that's pretty much the lesson of lesson 2. It's basically looking at relationships and creating an equation. So I hope you understand it. And I will see you next time on Young Learning. All right. I'll see you later.